In our list, we have next is a router. But before I go to router, I have to quickly repeat the difference between a bridge and a switch. Bridge, as we learned earlier, it is a software-based device, which means the entire switch functionality load falls on the processor and the operating system that governs the motherboard. In order to do some sort of filtering, you don't have any specific controllers, means chips. You don't have any kind of uh, mini processor with a mini operating system that can be acting like a supporting processor for the main CPU, main processor. So the load will be too heavy as a result because there is no helper for this main processor. The load will be too heavy. As a result, it cannot handle more amount of traffic from more number of device. That's the reason
Mm-hmm.
if someone filters traffic based on the MAC ACL, those filter policies are maintained in the TCAMs, means in the ASIC.
Mm-hmm.
So the processor need not to do all the functions. As a result, the process is available free to handle more
Mm-hmm.
traffics, more users.
Mm-hmm. Uh-huh.
That's the reason why switch has got more number of ports uh, compared to bridge. But we
Mm-hmm.
cannot say how many ports a switch can have. As I said earlier, it all depends on how many ASIC
Mm-hmm.
we have.
Okay.
More ASIC, more number of ports, and also the fastness, how fast the ASIC is. Uh, Based on that, the switch throughput will vary. What is
Mm-hmm.
throughput? The amount of traffic that the motherboard can handle
Mm-hmm.
per second.
Mm-hmm.
So if you take some TB of if you take big switches, they can handle some TBs of traffic per second. Whereas some will be like few MB
Mm-hmm.
of traffic. So though both are called as switches,
Mm-hmm.
um, the capacity are not the same. So switches are now coming in various form. If you see some switches, they have very less number of port, but they are called as very big port and very fast port. How can a big port, sorry, a big switch, how can a fast switch have five ports, four ports, and we pay big amount of money to buy that one switch. But the other
Mm-hmm.
switch has got 96 ports. It is not so costly. It has got 96 ports and not so big.
Mm-hmm.
Uh, we pay less. Why is that? Why four port switch costs that big money and 96 port switch is hmm, less amount? So big or small, it is not based on how many ports the switch supports, how many devices can be connected. Today it is it's totally changed. Earlier it was like that. So
Mm-hmm.
even when I was talking about bridge, I said it can have only 25 ports.
Mm-hmm.
Um, but today it is not like that. Today, even if you have less number of ports, it is okay. Why? We started using some extenders.
Mm-hmm.
Extenders are like like remote modules, meaning if you have that high and big switch, as I said, with just few ports,
Mm-hmm.
from this one port you take and connect a 96 port extender. Now there are 96 devices connected to this, and there is another 96 port switch, another 96 port switch. Now you see how much volume it takes. All these 96 plus 96 plus 96 enters into this switch,
Mm-hmm.
and this forwards traffic for all these three switch members.
Mm-hmm.
So this one port can accommodate these
96.
96 ports traffic incoming and outgoing. You know,
Mm-hmm.
so it is only the ASIC inside.
Mm-hmm.
It's not the number of ports. It's ASIC. How is the capacity? How big is it? We have something called switch processor,
Mm-hmm.
switch fabric, switch processor, PHY, PHI, PHY, switch processor, NP, network processor, switch fabric, all these things for each port. As a result, more bigger this NP, more throughput it takes. More bigger the switch fabric, more amount of traffic it takes. Apart from this, it will also have a centralized processor to which all these are
Mm-hmm.
connected. So inside architecture is what makes the switch big or small.
Mm-hmm.
So it's purely based on the hardware. That's why switch is a
Okay.
hardware-based device. Now let us not.
Just one quick question, Jan.
Yes, yes, yes.
What is the switch fabric in P and the 5?
These are all again another components like ASIC. These are all another
Mm-hmm.
components that we have behind each port.
Okay.
Mm, these are all hardware. I'm just explaining these components because switch is called as a hardware-based device,
Okay.
right?
Okay.
These are the hardware components which is absent in bridge.
Mm-hmm.
So, bridge or switch, it appears to us same, the box size and
Mm-hmm.
but internally, the architecture, the chipsets, all vary.
Mm-hmm.
They are not the same.
Mm-hmm.
Okay. Now, similarities between switch and bridge, both are layer 2 device.
Okay.
Yeah. Why it is called as layer 2 device?
It forwards packet within a network.
Okay.
It works on layer to MAC address.
Okay. More.
Mm-hmm.
It is going
It
to.
doesn't fall. Okay.
It is
Sorry.
going. No. Carry on. I'm sorry. I interrupted you.
No, no, you can go ahead.
Okay. So it takes the forwarding decision based on the
Mm-hmm.
MAC address that is seen in the incoming packet.
Yep.
The,
Source MAC.
yeah, destination MAC.
Uh-huh.
Destination MAC. It learns the source MAC, but
Mm-hmm.
forwarding decision is based on the destination MAC address.
Mm-hmm.
When a packet is received, the packet has got all 7 layers in it, but
Mm-hmm.
switches are interested in only the layer 2 address.
Mm-hmm.
They only deal with layer 2 address. They focus on that and they decide uh, on which port the packet needs to be pushed out.
Mm-hmm.
exit.
Mm-hmm.
Whereas on routers, it is based on the
IP
IP
address.
header. Correct, IP address, the destination IP address. So, because the forwarding decisions are made in this device based on the layer 2 address, MAC address, we call it as layer 2 device. Switches and bridges both does the same um, lookup called MAC lookup,
Okay. Mm-hmm.
and only based on the MAC address they forward. Now, both learns MAC address from the incoming,
Incoming source.
yeah, from the frame. It looks into the incoming source and it learns the MAC address, and it's the same here also. Now we are writing similarities, right? So they learn MAC address. How many MAC address in a port a switch can learn? There is no limit like that.
Mm-hmm.
A port may learn many MAC address. If
Mm-hmm.
there are packets coming with new MAC address, the port will start learning it. Port will
Mm-hmm.
learn it. So it's not like one port only one MAC address. Uh, as I showed you sometime, means few minutes before, you got a big switch with 4 ports, and each port are connected to 96 port extender.
Mm-hmm.
Then you will have
Mm-hmm.
96 MAC address there, because 96 devices are going to be consolidated and pushed into one single port on the upstream device.
Mm-hmm.
So there is no limit for learning MAC address, but the device have got limit. To maintain MAC address, there will be a buffer, and
Mm-hmm.
that will have a limit. Usually, the buffers will accommodate 4 times more than what uh, the normal network needs to learn. But if there is some attack, MAC spoofing attack, MAC flooding attack, there
Mm-hmm.
are chances that the buffer may overflow. Anyway, we will not get into security right now. We'll do it later. So,
Mm-hmm.
for every um, for every layer two, layer three, or tables, there are limitations, hardware limitations. But
Mm-hmm.
the software is ready to accept any number of MAC address that comes against the port. Learning
Okay.
MAC address, MAC address from the incoming source of the frame. Next is, if destination is not known, if destination is unknown, flooding happens. In both.
Mm-hmm.
And in both, you got dedicated collision domain on each port. Right? So, similarities. These are all similarities.
Okay.
And the only dissimilarity that we have is software, that is hardware based device. Now, let's
Okay.
move on to the next one. Though the switch is very smart, the switches don't understand the layer 3 information. Switches
Mm-hmm.
cannot connect between broadcast domains. Switches will have one broadcast domain by default, but by creating VLANs, We can have multiple broadcast domains. Each VLAN will have a separate broadcast domain, but
Mhm.
they are not going to allow you communicate between the broadcast domains. Switches don't have that capacity to understand
Mhm.
layer 3.
Mhm.
They don't know how to bridge between broadcast domains, how
Mhm.
to route between broadcast domains. Um, if it's a multi-layer switch, yes, they do. We do inter VLAN routing, but I'm talking about a simple switch. A layer
Okay.
2 switch cannot do layer 3 routing.
Mhm.
So we need a routing device to route packet from one network to another. Uh, so we need router. Now this
Yep.
entire course focuses on these two, switch and router.
Mhm.
Router, router is called as a layer 3 device, and you know the answer because we see these devices take decision based on the uh,
Right.
IP address on each packet in the layer 3 header. IP, it reads the destination IP in the layer 3 header. In layer 3
Mhm.
header, there are many fields: protocol field, version field, offset field, TOS fields,
Mhm.
many fields in which it shows interest on that destination where the packet is going, and then looks
Mhm.
into the routing table. In the
Mhm.
routing table, it finds the destination's network, the maximum prefix. If the destination of the packet is 100 or 100 or 100 or 100,
Mhm.
then it looks into the routing table, and you got
Mhm.
a route saying 100 or 100 or 100 or 0 slash 24. You need to send it via G0. You got another one 100 or 100 or 0.016, and you see via some other port, maybe G5. So the maximum matches here, because here only 16-bit matches, whereas here
Mhm.
24-bit matches, so it pushes the packet via G0.
Mhm.
Now, layer 3 decisions are nothing but routing decisions. Routing
Mhm.
decisions are done only on routers, not on the switch. That's why switch cannot be a layer 3 device. A router only connects between multiple networks. And every port on a router has got a dedicated collision domain as well as the broadcast domain.
Mhm.
Switch by default has got only one broadcast domain,
That's
but
right.
while creating VLAN, you create more broadcast domain. But but the routers, by default, every port will be in different broadcast domain.
Mhm. Mhm.
Every router, they belong to different network, means each network is a separate broadcast domain,
Mhm.
separate layer 2 domain, separate layer 2 domain, broadcast domain, all are same. Say separate network they belong to. So each router has got a broadcast domain. So in case if there is a layer 2 broadcast in the LAN, there is a LAN
Mhm.
and there is a layer 2 broadcast, and now that broadcast will impact, because it's a layer 2 broadcast, switches will forward the broadcast. It will impact all these PCs. But if there is a router here which has got two LANs connected, and it is there to interconnect between these two LANs. So I have a router. F00 is one interface, F01 is another interface. Now these two connects to LANs, LAN 1, LAN 2. Now when a layer 2 broadcast happens, there are various reasons why layer 2 broadcast happens. So, it may be
Mm-hmm.
ARP,
Mm-hmm.
and this flooding goes only up to here. This device receives, this device receives, this device receives the
Mm-hmm.
flooding, this device receives the flooding. Even this port also receives the flooding because this also belong to the same LAN, but this port is not of the same LAN.
Mm-hmm.
F01 is not of the same LAN.
Yeah.
So routers, they don't allow the broadcast packet to go to the other port. That's why there is an X mark. You don't allow the flooding to move further. It won't pass on to the other side, which
So
means
if we have a default gateway, does it?
no, nothing.
No.
No.
Okay.
So the routers, they don't allow the flooding. They don't
Mm-hmm.
allow the flooding uh, that comes on one port to go to other port. No flooding.
Mm-hmm.
No flooding. If a packet comes with a specific IP address, I'm
Mm-hmm.
trying to answer your question. If a packet arrives on F00 with a destination, when there is no route in the routing table for that destination, then it will use the default route.
Okay.
And the default route you may be pointing towards this interface, out
Mm-hmm.
via this interface. But the packet was not having broadcast IP address as a destination. The packet was having a specific IP address, a specific destination to go.
Okay.
For that, it will use a default route. When a layer 2
Okay.
broadcast packet comes, router has got nothing to do with that. It won't forward to any port. That is why we say there's a broadcast domain on the port, meaning I asked you to interchange the word domain with
Control.
controller. So there's a broadcast controller there. Every port stops the broadcast. It won't allow the broadcast to go further. You
Mm-hmm.
don't pass it on to any other port.
Okay.
So routers, every port has got a collision domain and the broadcast domain. Collision domain and the broadcast domain. Fine. Now, more about router we will learn later. Now, there's a small exercise we'll do to understand this broadcast domain and collision domain, and then we'll move
Okay.
on to next topic. Here, let us say we have a hub. And the hub will have 8 ports.
Report
Now this hub is,
device.
is connected to a switch
Mm-hmm.
of 24 ports.
Okay.
Now, how many broadcast domain we have and how many collision domain we have?
In total,
Yep.
8 plus 1 broadcast domain.
What happened? Please.
8 plus 1 broadcast domain.
Why you say like that?
So the hub is a 8 port which has
Hmm. Yes. Yes. Hub is 8
and
port.
this
No, 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 no. Complete the statement. Hub is 8 port and which has what?
which has 8 broadcast domain.
Oh no. No.
Sorry. Am I confused?
Yes.
Switch has a single broadcast, right?
Hub and switch have only one broadcast domain. Okay.
Okay.
Hub has got only one collision domain and only one
Yeah,
broadcast
one.
domain.
Yes.
And
Yeah,
switch, you can increase the broadcast domain by creating VLAN.
VLANs.
But by default, it is only one. What does that mean? If any broadcast hits one of the port, it will go via every port on the device. That is what single broadcast domain, because they're all under single group. On hub, you cannot break this group, meaning you cannot have more than one broadcast domain. You cannot create VLANs in hub. So they always remain one. Broadcast domain remains one. Whereas in the switch, though it is having only one broadcast domain initially, but later if you want, you can break down the broadcast domains by creating VLANs. Anyway, that is not our story. We have a default. Now a switch is connected to a hub and switch is 24 port. What will be the broadcast domain and collision domain in total?
Collision domain for switch.
No, both together.
For switch, we have one collision domain.
Oh
And
no. Why you're confusing yourself? No, you're confusing yourself. Let us now go back, please. Understand, hub have always one collision domain and one broadcast domain. Switch, every port can learn MAC address and have their own path, so that they need not to broadcast all the time. When they don't do broadcast all the time, they avoid collision. So if you have 24 port switch, how many collision domain you have? How many collision
20.
control? Yes. And one broadcast domain. Correct. Now, if you need any clarity on this, if you are confused anywhere, please ask.
No, I'm good. Sorry, I
Now,
got confused.
yeah. Now, uh, tell me this total, how much we have?
So the broadcast domain will be 2, and the collision domain will be 25. Switch have 24 ports, and for hub we have one collision domain, so it will be 25.
Okay, but I want you to rethink, please. Can you try to think more deeper? You say 2 broadcast domain and 25 collision domain, right?
Yeah, 2 broadcast domain, and the switches of 24 ports, so it would have 24 collision domain.
Okay. Now you see, I got a computer connected to all the ports. Now this computer is doing a layer 2 ARP. ARP is a layer 2 broadcast packet, right? Now the broadcast hits this port. As soon as it hits this
It
port,
forwards.
it floods, right?
Yeah, it floods.
So all these ports.
Okay, it connects to that one.
All these ports floods, right? Now how many collision domain I have? Sorry, how many broadcast domain I have?
So broadcast would be 1.
Very good. That's all. See, if a broadcast will go to all these, then they're all in one group.
Yeah.
They are one group, only one broadcast domain.
Okay.
Even if you connect 100 switches, they are going to have only one broadcast domain.
Okay.
Only when you create more VLANs, the story changes. The
Okay.
default, all the ports are in one broadcast domain called VLAN 1.
Mm-hmm.
So even if you have another switch connected here, the broadcast that is coming here, it is entering into VLAN 1 broadcast domain, which is
Mm-hmm.
also extended here. So everyone here will receive that flood because this
Yes.
port belongs to VLAN 1.
Mm-hmm.
So even if I have 100 switches, it is going to be only one broadcast domain.
Okay.
It's a very bad design because every now
Mm-hmm.
and then there will be always some layer 2 flooding. If you
Mm-hmm.
keep adding more switches like this in a serial way,
Mm-hmm.
the impact of the broadcast will bring down the network.
Mm-hmm.
So we need to have layer 3 routers everywhere to control the broadcast. We need to put them in multiple subnets and put them in different VLANs and use routers to interconnect between the subnets so that you will have multiple collision and broadcast domain because every port on
Mm-hmm.
a router has got a collision and broadcast domain.
Mm-hmm.
Okay, so you said one broadcast domain, exactly right. It is correct. Now, how many collision domain?
Mm-hmm.
Forget about this newly added switch. We don't have this. Mm,
Okay.
yeah, sorry.
24, 25.
Mhm. You see, all these devices connected here, MAC addresses are learned in this port. Yeah,
Okay.
yes or no? Yes, no? Yes.
Yes.
And this never learns any MAC address. This has got only one common backbone, and that
Mm-hmm.
backbone is extended here. As a result, it is also extended here. So here there is no separate collision domain because you extended that collision domain to that backbone. That one broadcast domain that you have here is it's connected to this broadcast domain. As a result, this is the only controller right from here to this first port,
Mm-hmm.
the port which you connect, the
Yeah.
port. So this is only one
Collision
collision
domain.
domain and other 34 ports. So totally 24 collision domain. So
Okay.
whenever you connect, they
Mm-hmm.
share the collision domain. Even if I have
Okay.
a switch,
Mm-hmm.
another switch connected, and this is 24 port, this is 24 port. How many collision domain we have?
Uh, 24 minus 24 plus 24, 48 minus 2,
Minus one.
46. Because these two interfaces, this.
They share one collision domain. They have one common collision domain.
Okay, 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 okay.
Yeah.
Yeah,
So
yeah.
it's 47. Yeah. Right.
Mm-hmm.
Next, let us take a hub, a router, and a switch. And again, it is 24 port. Now, how many collision domain? How many broadcast domain?
So, mm, the router have only two interfaces, right?
Yeah, exactly. Only two.
Okay. 27 collision domain.
Okay, why you say that? See, we have 24 ports here,
24 port switch, yeah.
and hub 8 port or 6 port, that doesn't matter anyhow. Whether it is 8 port or 6 port, the collision domain is going to be only one.
Oh,
Now,
router has just one. Oh, I got
no. Router,
confused.
each port have got one.
Yeah, each port. So
Each
we
port
have
have got
connected to.
collision domain and broadcast domain. Yes. Now, what will be the total number of collision domain and broadcast domain?
So hub have one collision domain,
Hmm.
and router have two collision domain,
Hmm.
and the switch have 24. Okay, 24 minus 1, 23.
Hmm.
Is it 23? I'm getting confused with the switch
Hmm.
that connects with
See,
the router
because
get
it
minus.
no need to minus there. It goes up to here, right?
Mm-hmm.
So this is one collision. This is shared actually. So 24 includes this one.
Okay.
Okay, including this 24 because this 24th is shared up to here. This is
Mm-hmm.
24 and this one is 25. So 25 collision domain in total and two broadcast domain. Right? This side is one
Yeah.
broadcast domain, this side is another broadcast domain. So it's only 25.
Mm-hmm.
If you're not clear, let me know.
Now can
Earlier,
we go? Uh-huh.
yeah, that's what. Earlier, I took two switches
Mm-hmm.
and I said this 24th port is connected here to the first port or 24th port. So totally we have 24 port switches, 24 port switch here. And now I was asking how many collision domain we have. Each port
Mm-hmm.
has got a collision domain. Let's say here 23 port plus this 24 goes up to here, right?
Mm-hmm. Mm-hmm.
So this is 24. Remaining 23
23.
is there.
Mm-hmm.
So we got
40.
47. Yeah. Likewise, this one is up to here. So
Mm-hmm.
you got 24, right?
Yeah.
And this one is up to here. So you
Mm-hmm.
got 1.
Yeah.
24 plus 25.
Mm-hmm.
All right.
So how the broadcast domain?
Mm.
So the hub have one broadcast domain
Mm.
that's shared with router,
Mm.
and the switch also have one broadcast domain that shared the exact same way with the router,
Mm.
right?
Mm. That's right too, totally.
Okay. Okay.
So we should see like this: if a broadcast packet is sent to one of this port,
Mm-hmm.
till where it
Mm-hmm.
goes and stops, it goes up to here and stops. So this is also in that same group, same
Mm-hmm.
domain, same broadcast domain.
Mm-hmm.
Same way, if a broadcast packet is sent here, it goes up to here, which means these are all in
Okay.
one group. If it is in different group, it will not hear the broadcast. It will not receive the broadcast. Only when
Mm-hmm.
it is in same broadcast domain, it can get the broadcast packet. So if it is
Okay.
getting a broadcast packet, which means it is in the same group.
Mm-hmm. Mm-hmm.
All right. Now, um, if switches don't know a destination, it floods.
Yeah.
And as I said earlier, if switches are connected serially like this, that flooding will go to every device on all the switches.
Mm-hmm.
If this switch do not know the destination of the packet, If the switch do not know, it's going to flood to all the port, which includes this port, this link, this port in the link, and it comes here. If this also do not know, it is going to flood and disturb every device. All the device will receive the packet and they will drop it. This is not mine. Why it is coming here? So unnecessary broadcast utilized, process utilized. This bandwidth again. This is going to flood. This also do not know. This is going to flood. This is very bad design. Very bad design. So if everyone sends a unknown destination packet, then the think about the bandwidth utilized, the process utilized, not only on the switches, even on the receiving device. All those computers connected to other switches, for them it is an irrelevant packet. Their MAC address and the incoming frame MAC address doesn't match, so they unnecessarily receive it, they process it, and they drop it. To avoid this, we need to break down this big broadcast domain. That is why we introduce more routers. So when we have routers and when we have devices connected to a switch here, and then we got another switch here connected, we can control that broadcast because every router is going to stop. And now this is pinging someone. The destination is unknown to this route, to this switch. The destination is unknown to the switch. It floods the packet. It is received on every device in this LAN 1. Earlier we had only one LAN. This is one LAN.
One network.
Yeah, one LAN. One broadcast domain. That's what here I mean LAN. Yep.
Yeah.
In a practice, we do one LAN, one broadcast domain, one subnet, one network, as I said. That is also right. You are talking layer 3 perspective. Fine. So we got 4 LAN here, 4 different layer 2 groups. Whereas in the above, it is only one layer 2 group, one layer 2 domain. Now, when a flooding comes from this particular PC, it cannot move anymore. It will stop here. So these devices don't unnecessarily experience more packet. They don't receive the flood anymore. The flooding stops right behind the router. So the bandwidth is not here consumed unnecessarily. These devices don't unnecessarily process a packet which they are going to drop. So when a broadcast happens, when a layer 2 broadcast happens, the broadcast comes up to the router and router says, wait, where you want to go? Now whom it is asking? It is asking the layer 3 of that packet. Now this device was only looking into the layer 2 and it do not know where to forward and it dropped it. Sorry, not dropped it. It did not. It don't know where to send, whom to send. It flooded. Whereas where to go information may be there in the layer 3 header. Now this router is there to check that. Router says where you want to go. It is asking the layer 3 header, not the layer 2 header. And layer 3 header says, I want to go to that network. Okay, that network. Let me check the routing table. Okay, the routing table says you need to send via this link. You send here. So we don't waste any of other LAN's bandwidth and their processor. So introducing routers more in our topology is going to improve our network because we are breaking the collision domain. Sorry, we are breaking the broadcast domain into small pieces. If we connect switches simply without routers like this, the broadcast domain keeps increasing and the efficiency of the network will keep going down.
Okay.
So more network is better than a large network,
Mm-hmm.
for which we
More
need,
network
yeah, more
in the sense
networks.
adding more routers.
Yeah, of course, if you have more networks, then you will have more routers.
Mm-hmm.
When we have more routers, you will have more broadcast domain, broadcast
Mm-hmm.
controllers. Yeah, so more networks, more broadcast
Better.
domain.
Mm-hmm.
Yeah, more network, better network than a large network.
Okay.
Large layer 2 is very bad
Mm-hmm.
because DHCP will do broadcast, ARP will do broadcast,
Mm-hmm.
and that broadcast need to be flooded to everyone, which may not be really needed. So if the DHCP broadcast goes from one department, why should
Mm-hmm.
it go to the other departments in the organization?
Mm-hmm.
If it is going to every device inside the same LAN, it is okay.
Mm-hmm.
Why should it go to other department when there is nothing to receive from the other department? It's unnecessary. So we can put them in different VLAN, different subnet. If you don't have a VLAN,
Mm-hmm.
you can create a physical LAN like this. See here, I'm having multiple LAN because I don't have a VLAN concept. We have not learned VLAN, so I have not taken that example.
Mm-hmm.
So because I used physical LAN instead of VLAN, I need more
Mm-hmm.
routers.
Mm-hmm.
If I would have used VLANs, then I don't need these many routers. I need only one router, and I can do
Mm-hmm.
inter-VLAN routing, which we'll see later.
Mm-hmm.
So one thing we learned here is large LAN is bad.
Mm-hmm.
Smaller the LAN, better will be your network, more faster will be your network. Yep. So the flooding, the broadcast will not go
Mm-hmm.
to everyone in the organization. It will only impact that small LAN.
Mm-hmm.
All right. So that's the takeaway here. Next. So that takes us to the next level. What? VLANs.
Okay.
Instead of buying these many um, routers, what we can do is we can take one switch. Inside the switch, we can create virtual switches. By default, the switch will have one virtual switch called VLAN 1.
Mm-hmm.
Now, what we do is we break down this big VLAN, means one VLAN means one group of device. All ports are in same VLAN, which means all devices are in same group, same broadcast domain,
Mm-hmm.
which is bad. We saw.
Yeah.
So if I have 96 port switch, now all 96, if it sends a layer 2 broadcast, oh my god, it will be too much
Mm-hmm.
traffic.
Yeah.
So that's one reason why we have to break down this large broadcast domain into multiple broadcast domains. So we create VLAN 10, create VLAN 20, we can create up to 4096 VLANs. 4096 VLANs.
Mm-hmm.
We can
Mm-hmm.
break down that single broadcast domain into 4096 pieces.
So this one is logical and it
Virtual
is
switches.
okay.
Virtual switches. These are all switches, but virtually inside one hardware we create multiple switches. That is what VLAN is.
Okay.
Now earlier, when an unknown packet comes, the flooding was to all the 96 ports of the switch. But now the flooding, when an unknown packet enters this port, the flooding
Only
goes
96.
only to this switch, which means this is a switch only within this broadcast domain. So a VLAN is a switch.
Okay.
Switch itself is a VLAN by default, only one VLAN. Switch itself is a VLAN. Physical switch is a VLAN, one VLAN. That's why you connect a switch, another switch, another switch, another switch. They all form one broadcast domain because they all have one VLAN called default VLAN called one, number one. They all combine and form one big group. Yep. So interconnecting switches is a bad idea, but now you can interconnect. Why? Because inside that one physical switch, I have multiple virtual switches. So I can now connect switches like this. I can connect switches like this via a special, not special link, via a port type called trunk port. So now, even though physically I have three switches, virtually I have six switches here. Six broadcast domain, isn't it?
Yeah.
Six broadcast domain. So all VLAN 10 members in this three switch forms one virtual switch. So totally we have six virtual switches. Six virtual switches. That is nice. Six virtual switches. If you want more, if you feel like, oh no, still these switches are always busy, then again break down the broadcast. Again, you create more VLANs. And now, if you want to interconnect between the VLANs, then you need routing support, for which you may have one switch turned as a layer 3 switch, so that if anyone from this VLAN, let's say this is VLAN 10, and anyone from VLAN 13, if this computer, let's say computer H, wants to talk to this computer R, R can talk to H with the help of the layer 3 support here. So this will go all the way down to this layer 3 device, get routed, and then enter into this domain and talks to H. So a layer 3 is needed if you want to do inter-VLAN routing. That's later story. Let's not get into this. So what I'm coming to say is, even though you are breaking down into multiple broadcast domain, but whenever there's a communication needed, you can still communicate. That's what I want to say. You can still communicate. At the same time, you don't have broadcast too much. You don't have a large broadcast domain because of VLANs. So what is a VLAN?
Differentiating the broadcast domain and message.
Okay.
Separating.
Okay. VLANs are helping you to create multiple broadcast domain. That's right. VLAN helps to group ports into broadcast domain. And these ports may not be in the same switch, it may be in different switch. Regardless of the physical switch, physical location, you can combine port C. If this is VLAN 10, this is also VLAN 10. And if in this VLAN 10, if I have 5 port, and in this VLAN 10 I have 15 port, in this VLAN 10 I have another 15 port. So totally how many ports in the switch? In this virtual switch I have got 35 port switch. This is a 35 port switch. But physically they are not in same box. Virtually they form a separate box, 35 port switch. Likewise, we can create more VLANs, and we can have different size of switches. But this is a virtual switch again. The size of the switch is defined by the VLAN number. Yep. All right.